With these videos, we're aiming to create an online library where if you don't manage to come to Full Circle or any of our events that we think are worth putting up, you can come in your own time and look at this video and learn about the topic.
Hello everybody, my name is Dr. Aaron Davis and I'm Head of Coffee Research at the Royal Botanic Gardens, Kew. And today I would like to talk to you about Stenophylla coffee, Coffea Stenophylla. Before I do that, I just want to provide some context and talk a little bit about Arabica and Robusta. So as we all know, Arabica is sort of the chosen child of the coffee world. It's the favourite coffee for many drinkers, and of course the only coffee featuring in specialty coffee. And from humble beginnings in the forests of Ethiopia, it has become a major global commodity. And even at the beginning of the 20th century, it became a globally important crop for many tropical countries. This is Kenya in the 1920s. And had a successful cultivation history for about 400 years until a turning point, which was coffee leaf rust. The implications of coffee leaf rust in Southeast Asia were severe, pretty much causing Arabica to be wiped out within a few decades. Now, the response to that crisis was to introduce another coffee species. The first one that was tried was liberica coffee from West Africa. And although it grew very well and was pretty much resistant to coffee leaf rust, and we can see Arabica here suffering in the background, there was one major issue, and that issue was that nobody wanted to drink it. Nobody wanted to buy it. It just wasn't Arabica. And despite some heavy marketing, it bombed, it failed. Now, around about the same time, scientists and growers became aware of another species of coffee, which was Robusta coffee. Now, we might think today that Robusta has been well known for a long time, but in fact, it was only known to science in 1897. It was quite pretty much a new kid on the block. Now, there is evidence that it was traded by the Portuguese even in the 17th century. So it has been around a long time. It was cultivated in Uganda in the 1800s. But it's pretty much unknown until the beginning of the 20th century. And then what happened in response to the coffee leaf rust crisis, and also because it's hugely productive coffee, it started to gain ground over Arabica. You can see from this simplified graph here that it's gone from an unknown wild species to a globally significant multi-billion-dollar commodity in a really short space of time. I don't think there's any other crops that have quite achieved that ascendancy. So now we're approaching, or we're in another turning point for coffee cultivation, and that's the era of accelerated climate change. Climate change has been on the agenda for at least a decade or more, but I think it's only in the last few years that it's really starting to hit home, and producers are starting to report failures or issues with growing Arabica, and in some cases Robusta as well. Now, we've heard quite a lot about the risks and the jeopardy that farmers face through climate change, but key for me is actually how are we going to deal with this situation? What are the solutions? How are we going to act on climate change? And there are essentially three main pathways. That's to adapt, to change the crop, or to relocate coffee farming. When I say adapt, I mean adapt the farm, change the coffee growing environment on farms so that they're more resilient to climate change. Let's look at the first one of those, and perhaps one that does have some substantial benefits, particularly in countries like Ethiopia, which has a very large elevation gradient. And what we've shown there with our work is that actually, even under climate change, you can adapt the coffee landscape of Ethiopia to the extent where you can increase productivity 4 or 5-fold, even under climate change, across this century. And indeed, that is already happening. We're already getting the feedback that some farmers that have grown coffee for generations are not able to grow coffee anymore or are struggling. And there are farmers at high elevations who've never grown coffee who are starting to grow coffee for the first time. The only trouble is that although you can move coffee, moving people is extremely difficult and problematic and lots of social implications. So although it can have benefits in some countries, there are serious constraints. Now, in terms of adapting the farming environment, there's been a lot of emphasis on climate-smart agriculture, adapting the farm, employing such methods as mulching or increased shade, etc., or soil inputs. And what you see is that actually you can do a lot with farm adaptation. You can increase productivity, you can increase yield. But there are two issues here. One is that whatever you do, it's going to be difficult to counter climate change. So whereas it might work in the short term, in the longer term, you're not going to combat climate change. You're not going to keep up with the projected changes in temperature and other changes such as reduction in rainfall. The second disadvantage is that it's costly. So what we've seen in our work in Ethiopia is that although you can, in fact, double yields in some cases, the cost is so prohibitive that actually the farmer ends up losing money. So, and what we realised after a fairly short period of undertaking this work is that farmers knew what to do or know what to do, but they're reluctant to do so because of the cost. And that's clearly an important consideration. So looking at the third option as to change the crop, and this is where we feel there's perhaps more potential, more scope, particularly on a decadal time scale, across this century. So I think what happened in coffee research over the last few years is that people have looked at two main routes for changing the crop. And people were saying, well, surely there's an Arabica that's more heat tolerant and more drought tolerant. But what we've seen, particularly our work in Ethiopia, that there isn't really that potential. There might be short-term gains, some improvements, but again, it's not going to counter climate change. So looking at Arabica for a solution on its own within the natural genetic diversity, I don't think is going to be a long-term option. Now, Robusta is often mooted as a replacement for Arabica, and there certainly are many circumstances where that offers great potential. Of course, there's a price differential. Some farmers don't want to grow Robusta, but it does offer some potential. However, recent work has shown that Robusta is actually more heat sensitive and more drought sensitive than previously supposed. So I don't think it's going to be the panacea that everybody's been looking for. We need something else. We need to broaden that portfolio of coffee crop species. So what we've been doing at Kew, and there's also other research institutes who are looking at this, is what is the potential in the other coffee species? So we grow two species, Arabica and Robusta. There are another 122 species of wild coffee. What potential is there to try and adapt the coffee growing sector to climate change? Now, we published this paper in 2019, and it was mostly focused on the extinction risk to wild species. And what we say in this paper is that of those 124 species, 60%, including Arabica, are in danger of extinction. What we also say is that these wild species and the wild diversity, wild genetic diversity, is also key to sustaining the coffee industry as we canter across this century. Now, that might seem a bold claim, but if you look back at the history of coffee cultivation, that's exactly what we've done. We've used Robusta to shore up the sector in that case as a response to coffee leaf rust. So it's already happened, but because we're entering an era of accelerated climate change, we need some real step change. We need some real dramatic solutions to what's happening. So if we look at the family tree of coffee, this is a family tree constructed on genetic relationships and group species together on their relatedness, how close they're related to each other. And what we say in that paper is that there are a group of species in Africa which house that potential. And what we did was we produced a priority list of where we should be looking for solutions to climate change and other issues. So wild coffee species occur right the way across the Old World, from West Africa right the way through to Australasia. So when I talk about species, I'm not talking about cultivars or varieties of Arabica. These are completely separate species, unrelated to Arabica, and in most cases unrelated to Robusta. Now, if you look at the priorities within the wild species, the focus is clearly Africa. That's where the real potential lies, and particularly as you have a diverse climatic profile across Africa, from very dry conditions where some coffees occur to very wet conditions, some very hot, some cooler, some wetter, some drier. Now, I think for many people this seems like, and I've heard it called science fiction. People think we're really being a little bit esoteric when we think about the other species, but I do think that there's real potential. And I want to discuss one example today, which is the focus of the talk, and that's Stenophylla coffee, or the Highland coffee of Sierra Leone, or just called the coffee of Sierra Leone. Now, my experiences and history with this species goes back a long way, probably at least 15, possibly 20 years, when I found a jar of the green coffee beans in our ethnobotanical collection at Kew. And one of the quite a few things that really piqued my interest, and looking at this jar, one of those was one of the things that it said on the jar was cultivated in the lowland ground. Now, coffee's not, particularly Arabica, is not a lowland species. The other thing was that the coffee beans were of roughly equivalent size to Arabica. This is parchment and green beans, although these were collected in 1873, so they've gone a little bit aged, I would say, over that time. And then I started to look at our other archives, and I found this rather charming picture taken in Trinidad around 1900. And it was interesting to me for a number of reasons. One is that Demerara sugar occurs in quite hot places, it's with other species that are quite dry adapted for tropical species. And also, if you were to zoom in on that picture, you'll see that actually that tree is really quite packed full of fruits. So it's unlike some wild coffees which don't produce many fruits, this has quite a good yield. The other thing is that this is a coffee from hot West Africa. And if you read the literature, of which there's a fair amount, it was also reported to be drought tolerant, which is also clearly a key characteristic if you're interested in climate resilience. And also it's resilient to coffee leaf rust. So it's starting to look rather interesting, and I'm not the only person to be aware of this, of course. But I think what is of interest to most coffee folks and coffee research scientists are the reports of its amazing taste. And if we look at the report here by George Don, and George Don was the person who described Stenophylla as a new species, there's a really interesting end to one of the sentences where he says, compared to Arabica, some people consider it superior, which really starts to become exciting. And then between 1830 and around 1920, there were several other reports, and they were all saying similar things. Here, one from Auguste Chevalier, who was an excellent coffee research scientist and really knew a lot about wild species, and he said that this is an exquisite coffee. And I think there was only one, in all the research that I did, there's only one negative report for the flavour of Stenophylla. And that's great, so it's all very exciting. But where was this plant? Nobody seemed to have it, nobody seemed to be growing it. We had plans to visit Sierra Leone and to try and find this species or to find somebody who knew something about it. But of course there was the Civil War, then there was Ebola, so the opportunities were few and far between. It's an interesting species in that it's very distinct. It's very different to Arabica, and if you see this in this early illustration, the flower has 6 to 9 lobes compared to what you would find in Arabica or Robusta, which is 5. So that in flower it looks very different. The leaves look quite different because of this elongated leaf tip, and the fruits are black. Which is different to Arabica and Robusta, of course, which are mainly red. And the reason why we wanted to go to Sierra Leone is that although we knew this plant was in some research collections, all the ones that we visited, there was like 1 or 2 plants, it was rarely fruiting or very, very rarely flowering. You don't reinvigorate a species with just a few plants, so we wanted to find it in considerable numbers. Here's a picture of the star-like flowers. So in at the end of 2018, December 2018, we had the opportunity to visit Sierra Leone, and our original intention was that we would try and find it on a farm. So we'd sort of kickstart the process by finding, a farm with maybe a few thousand plants, and initial forays were unsuccessful. Nobody knew anything about it. Nobody knew, any of the ministries knew anything about it. None of the farmers, none of the coffee people. So what we did was we made a wanted poster, which was distributed across the coffee region, and that only turned up 2 possible sightings, both of which turned out to be Robusta. So what we did was to go back to the last place it was seen in the wild in Sierra Leone, which was in 1954, which is a long time ago. And there's been a lot of deforestation during that period. Eventually we got to this, the last known site, and although there was a lot of deforestation, there was some forest left on the hill, and after a few hours trekking, we got into the forest and we actually found 1 single plant. That was it, nothing else. And 1 plant is no good, of course, for coffee because you need other plants to be able to make fruits and seeds. So the good thing about finding the first population is we knew roughly where to look, what sort of environment, what sort of forest type. And Daniel Samu, who was a Sierra Leonean chap who was working with us, said, there's a forest near where I live that's a bit like this, let's go and have a look. So we travelled over towards the Liberian border. Again, another hot, sticky romp through the forest, and we did in fact find more plants. In fact, we found quite a lot. Fantastic. I mean, this was very exciting. The only trouble is there were no flowers, no fruits. So although it was, it was great, what we really wanted to do was get some fruits and get the coffee cupped. So we actually had to wait until April, May 2020, and what Daniel did was to keep going back to the forest until he found this species in fruit. And you can see he's doing some very rudimentary processing on these fruits here. And in May last year, we received 60 grams of dried green No, sorry, actually it wasn't. It was cherry, and when we processed that, it went down to 9.8 grams. That's all we had. Then COVID kicked in, so we couldn't get it cupped, so we had to wait. But eventually we managed to get it cupped in London. So we did this at Union Hand Roasted Coffee, and we were doing some other coffees as well amongst Stenophylla, and I must say our expectations were very low, having cupped lots of wild species, including the ones we've cupped here at Wakefields. And generally, I think everyone would agree they've been a little bit disappointing or a little bit weird and not really suitable as beverage species. So I think we were kind of the opinion that if it tastes okay, then that's fine. That's probably going to be good enough. But I must say, even the first interaction with the coffee was really remarkable. I mean, just the dry fragrance, it smelled, like Arabica. And we only had 9.8 grams. We applied the SCA protocol or a modified protocol because we didn't have much coffee. And this is all we had here in this picture. And it was quite remarkable because it tasted like Arabica coffee, which for reasons I'll explain later, you would not expect. And it even tasted so much like Arabica that two of the panel said it tasted like a Rwandan coffee. It had a bright acidity, fruit-driven flavours, and natural sweetness. And in a blind cupping, I would defy anybody not to think that sample was Arabica. So we'd actually published another paper earlier that year, and unbeknown to us, Sirad had this coffee growing in Reunion Island at the coffee research centre there in quite large numbers, which we were totally unaware of. And you can see a picture here of those black fruits. And unlike the other circumstances where we've seen this species in research collections, it was doing really well. And you can see the number of fruits. It's not Arabica, it's not Robusta, of course, but that's really reasonably productive for a wild species. So they were able to put together a substantial sensory sampling, which they invited me to, and I couldn't attend because of the COVID restrictions. And it couldn't have been more different from our little preliminary cupping at Union, where we only had that 10 grams. They had almost a kilo, and they did a very thorough job of the evaluation. They did a full blind cupping. They used controls, and they even did it under UV light. So the panel, of which there were 15, couldn't be persuaded or biased by the colour. So we decided we would collaborate on this because it was for us super exciting, and we published a paper in April this year, and the paper split into two parts. One talking about the sensory side of things, and the other talking about the climatic tolerances or profile of the species. So this is a sort of summary diagram of the cupping. And there's a few interesting things here. We had the Stenophylla, we had two Arabicas and a Robusta. And Stenophylla was, according to this analysis, was more Arabica-like than a Brazilian Arabica, which is kind of, not quite remarkable, I would say. Not quite as high quality as a speciality Ethiopian, but very different to Robusta, and, as I say, better than that low-quality Arabica. And then there were some questions for the panel, a series of 4 questions. So the two perhaps most interesting are, is this Arabica? Yes or no? And 81% of the panel said it was Arabica, which confirmed our earlier preliminary sensory analysis. And interestingly, over 40% said it was something different to Arabica. So that's why we coined the sort of use of the phrase Arabica-like, because it's Arabica-like, but not exactly Arabica. Now, for me as a biologist, I find this as a coffee nut really interesting, because up until now, the sort of golden rule is that high quality coffee is Arabica from high elevations, and that's been well looked after. And this is not a high elevation species. This is a low elevation species from sort of 100 to 400 meters, where Arabica wouldn't grow, but Robusta and Liberica would. And if you were to take a plane from Ethiopia after visiting the highland forests, where it's like a cool tropical environment, sort of 18 to 22 degrees, and you went over to Sierra Leone, the minute you got there, you think that this isn't Arabica. It's too hot. It's much, much warmer, and it just doesn't feel like a quality coffee location. And as you can see from this map, Stenophylla comes from Upper West Africa, which is nearly 5,000 kilometers away from Arabica. A very, very different geography. It's unrelated. It's not a sister species. It's not a hybrid of Arabica. It's in a completely different part of that family tree. And it looks, as you've seen from the photographs, it looks very different as well. So you would never expect that flavour profile from those conditions. So that was certainly noteworthy. And then when we did the climate profiling side of things, what we did was to look at Arabica, Liberica, Robusta, and Stenophylla. So to look at its basic climatic parameters and to see how they might differ. So these little dots here are Arabica, and as you can see, it's cool and it's fairly wet. Whereas Liberica, Robusta, and Stenophylla are on this warm side. Now, yeah, some of them are a bit wetter, but most are still in this similar rainfall profile to Arabica, which is really exciting. Also, these are the Stenophylla samples, and what you'll see is that it grows over quite a range of different rainfall patterns, or rainfall amounts. Now, when we started to look at the temperature, what we saw was that it was about 2 degrees warmer where Stenophylla grows compared to Robusta, but a whopping 6.2 to 6.8 degrees Celsius warmer than Arabica. Again, going back to that flavour profile, that's a huge difference. And so when we published the paper, what we were saying is that here we have something that's like Arabica, but is extremely more heat tolerant. Now, some of you may remember we did a press release around this with our partners, and it got a lot of media interest. I think because it was more about a solution rather than establishing the problem, which has prevailed in climate change coffee research. And although some of the press work was stretching it a bit, a rediscovered, forgotten coffee species, Bruce promised a coffee future, or even worse, some big claims anyway. That's the press for you. But even though a lot of those stories were exaggerated, this is what we say. This is what we say in the paper, and we say this species substantially broadens the climate envelope for high quality coffee, and could provide an important resource for the development of climate resilient coffee crop species. Now, So what does that future look like? And I think there are two main things. One is that it would enable coffee farmers in low elevation situations that are growing lower value Robustas to grow a high value specialty coffee. And what I didn't mention was that the SCA score was over 80 points, 80.25. So it does come into that specialty category. What you have to remember that also, if you read the paper, that score was based on a very small sample, as I've said, but also with suboptimal processing. It was dried in 3 days out on a patio and then shipped to us. No resting. It's just very minimal processing. So to get that score based on that sample is quite remarkable. But I think where it really could have a benefit longer term, and particularly in the sort of more commodity level sector, as a sort of mainstream crop species, is plant breeding. Now the problem has been so far is when we're breeding coffee leaf rust resistant varieties and climate resilient varieties, we're using Robusta. And when we do that, we're introducing some of the negative sensory attributes of Robusta, which has always been a problem, particularly in terms of farm gate price and marketing. It presents a problem. But if you have something that is extremely heat tolerant and coffee leaf rust resilient, then you've got two really useful attributes. And I think James Hoffman, we were able to send him a small sample to put on one of his videos, and that was to give as many people as possible the kind of feeling of what this coffee might be like. And he was under no obligation to say it was good or bad or whatever. But interestingly, he put it pretty well. He sees this as a chink of light, hope, that there is something out there that can really make a difference in terms of the problems that we're going to face or are facing with climate change. And I think we have to be incredibly optimistic. Otherwise, I think we're pretty doomed. And I think we are being optimistic. We're trying to head for net zero emissions. And I think we have to do as much as possible and be as optimistic as possible if we're going to meet the challenges that we're going to be facing. On the flip side of that, we have to be realists, and I think the Stenophylla story is an interesting example because Stenophylla is amongst those 60% of those coffee species that are threatened with extinction. Now, we estimate that if we would have been looking for Stenophylla in 10 years' time in Sierra Leone, it wouldn't be there. And if it wasn't there, we would lose or have lost that opportunity. So we have to really make sure that we safeguard the biodiversity that's left, because that biodiversity could provide the solutions for our future. And there's a lot of talk about carbon neutrality, and carbon credits within coffee, but I think we also need to focus attention on biodiversity loss and the threats to biodiversity caused by coffee, but also try to emphasize where there's potential for coffee to preserve biodiversity, such as forest coffee production in Ethiopia. And I think we've got a long way to go with certification that's meaningful in terms of advising the coffee buying public what influence their coffee buying decisions have, because they could be causing deforestation or preserving forest and biodiversity. So I think that's something we really need to work on. And I think we've tended to isolate the climate crisis and the biodiversity crisis. But the Stenophylla story shows that, and many other stories show that they're so closely interlinked that I don't think they can be divorced. They're part of the same issue. I think that's something we really need to address in the coffee sector. And that's it. So thank you very much for listening.
Right. thank you so much for that presentation. It's a brilliant presentation, Aaron, and I'm really excited to now continue on with a bit of Q&A. I've got a few in the chat, but just to start us out, I just wanted to pose one to you, which is when we're talking about Café Stenophylla and we're talking about the potential future for it, are we talking about planting more Stenophylla? Are we talking about crossing that with other species? Are we talking about using that on rootstocks? What's kind of the current thinking around that?
Yeah, that's a good question. I think the immediate emphasis will be on getting it back into cultivation in those countries that already have it in their wild forests. So countries like Sierra Leone and Ivory Coast. They're countries that have a coffee industry, they have a coffee sector. And they're already seeing the potential to grow it as opposed to liberica and Robusta.
Right. And because Arabica is a kind of tetraploidy, kind of self-pollinating species, what is Stenophylla?
Yeah, so Stenophylla is a diploid. It requires another plant to cross-fertilize like Robusta. So that does have some implications in terms of the development of the plant. You have to think about that variation in your propagation strategies. But there are mechanisms and routes to overcome that, to make it like Arabica, but that would involve crossbreeding with another species and the production of a tetraploid, which is doubling the chromosomes. So yeah, I think the key thing is that it's really early days for Stenophylla. It's like starting coffee research on Arabica from day one almost. There's just so little actually written of any value that helps devise an agronomy program for the species. But I think it will come. I think those farmers, say in countries like Sierra Leone, who are earning very small amounts of money from coffee at the moment, I think it's the risk is negligible compared to what they're going to possibly lose from trying Stenophylla. So and there's a lot of interest in countries like Sierra Leone to redevelop this crop, because one of the things I kind of didn't really mention in the talk was that this species was grown at scale in Sierra Leone, Guinea, and Ivory Coast up until around 1910. And it was exported to Europe as a specialty coffee. It had a differential because of its improved flavour. That all fell apart when Robusta came along, I think that's the reason, because here was a coffee hugely productive, disease resistant, and I think it just pushed everything else into the long grass, so to speak.
And do we know then how long kind of flower to fruit this particular species takes, and then kind of how long that would take to kind of reintroduce and kind of get a stable population going?
Yeah, there's various reports. Some say 10 years. But if you look at the speed at which, so Kew, where I work at Kew Gardens, back in the late 1800s, 1900s, one of its major functions was to distribute plant material. If you look at some of the ephemeral or hidden literature from the growing manuals, you'll see that within 4 years it was fruiting, and they were able to send seeds to Trinidad or wherever. So I think if the conditions are right, it could be, say, 4 to 5 years. But I would estimate there was another report from Java back in the 1930s, which was estimating or reporting 4 to 7 years. So it's not that dissimilar to Arabica.
Fair enough. Okay, let's go to actually just on the back of that. Got a question from Jamie, and he's saying that the picture you showed in Trinidad showed a bush full of cherries. Yeah, in one of the quotes it mentions low yielding. So these would seem to contradict each other, but is there a reason how or why? Is it terroir? What's going on there?
Yeah, so one of the things I flashed up on the slide and I didn't mention was one of the negatives that's always been associated with Stenophylla is low yield, particularly compared to Arabica and Robusta. And again, that's one of the reasons why it didn't get traction in the early 1900s. I think so. Yeah, I think terroir and origin, where it's grown, how it's grown, will make a big difference. I mean, as the talk went on, I added another slide, which was sent to me by Sirad, and I was just amazed to see how much fruit was on that bush. It's not Arabica, it's not Robusta, but yeah. So things have changed, and I think it will enter the market. It's a very high value crop. I'm sure of that, and so that will outbalance the yield until there comes a time when people have said, right, I've tasted Stenophylla, or the craze is over, perhaps. But actually, genomic studies of plants, particularly model species, shows that increasing flower and fruit number isn't that difficult. Compared to producing a flavor profile, which is a multi-genic system, there are very few genes involved in developing more flowers and fruits. I think the other thing is, and this links to another question that saw come up, is that there is quite a bit of variation in Stenophylla, genetically and physically. And what we see from some of the early collections is plants with more fruits. So that this search is on to find the most suitable type of Stenophylla in terms of agronomy, in yield and taste.
That's really interesting. I've got a question here that Dave Ray, and he says, on the topic of planting breeding, will crossing Stenophylla with Arabica be a faster solution as compared to building Stenophylla farms? I think for me here, so two interesting things with the question. One is what kind of time lags are we talking in terms of getting Stenophylla to being a productive plant that will actually be seen in the market? And two, do you see Arabica or Robusta as being a potential better crosser with Stenophylla?
Yeah, that's a really good and interesting question. And I think the key thing here is we don't want to produce another Arabica that tastes like Arabica or has the same environmental requirements as Arabica. There's no point. We need to. Our aim is to produce something that tastes like Arabica, or as good or as interesting, but it's more climate tolerant. So yes, you could back cross to Arabica. You'd have to take it from its diploid state to its tetraploid state. That's kind of a bit of science there that, of course, is biologists, but essentially you double the number of chromosomes, and then you can cross it with Arabica and other species. So you could cross it with Arabica, and I'm sure that would produce something really interesting, particularly in terms of the flavor profile. But it wouldn't. I don't think it's going to give you much in terms of climate resilience. So Robusta would be a candidate, I think. We know we can improve the flavor of Robusta by crossing with Arabica, so that's possible. But I think it's some of the work we're doing now is actually doing that. It's looking at the candidates or the partners that you would pair Stenophylla with. We, in our paper in 2012 on reporting on Stenophylla, we talk about a hybrid between liberica and Stenophylla, which is already in cultivation or already in propagation in Sierra Leone, and that is really robust. Not robust in terms of Robusta, but it grows fast. Its growth is even. What we're not sure about yet is whether it's going to produce fertile flowers and fruits. And we're not sure whether it's in its diploid state or tetraploid state. So there might be a bit of work there to produce that more productive plant. But yeah, some of the work has already been done. Another thing we say in both papers is Stenophylla actually has a good crossability. It has good crossability potential with other species. Some species are really difficult. Stenophylla seems to be pretty good. So yeah, I think there's if you have Stenophylla and other species, then there's a lot of work that needs to be done around plant breeding. I think it has to be done.
And going back to the species in general, and appreciate I did ask this question when you were in the office last week, but it'll be interesting to raise it again. Obviously, in your presentation, you showed a really big spread of species, and I think it was around 50% of wild species come from Madagascar. I was wondering if you could just expand on why not much attention was paid to them in the presentation, and why you sort of excluded them from the analysis.
Yeah, that's another really good question. Interestingly, Madagascar has a greater species diversity than Africa, the whole of Africa, which is amazing. It has some like nearly over 60 species, whereas Africa has about 50. A lot of work was done by French researchers in the 60s and 70s, and even ongoing, including chemistry work and sensory work. The trouble is that during the evolution of those Madagascan species, the caffeine pathway has been altered or changed, and many of those coffees are either zero or low caffeine. There's a few that aren't, and those the acids that produce the caffeine have changed, and when you cut the coffee, it's extremely acidic. I mean, mind blowing. I mean, yeah. But again, I think that a lot of that work was done a few decades ago. I think we need to revisit that. I still think it's interesting. Again, some of the interesting work that the French have done shows that you can, if you work hard enough at it, you can even cross the Madagascan species with the African species. And looking at the Madagascan species from a physical and climatic standpoint, it's mind-blowing. I mean, there are plants with very, very dry conditions. Coffee plants that look nothing like Arabica, Stenophylla, or any of the others we know. So yeah, it's that diversity is there, and it could still play an important role.
Right. So I guess on the continuation of that, then a couple of questions more from this side. One from myself is just more around when you're thinking about those kind of crossings in the future and looking at, say, crossing with the Robusta or crossing with liberica, is it the idea around crossing in one direction or also crossing back? And would you be wanting to cross back to Stenophylla or cross back to liberica if you were thinking to?
Yeah, I think that's, again, I think that's a really tricky one. There is data, there are studies that would give you some steerage on exactly what to do. But I think a lot of it's chance, luck as well. And just trying as many things as possible. And I think when it gets, as I'm sure it will, when it gets out into producers, they will start working with it themselves. So we did a cupping on Friday, and one of the hybrids on the table was mind-blowing. It wasn't produced by a research laboratory or a research institute. It was done by a grower. And a lot of significant advances in coffee breeding and coffee development have not necessarily come from research labs, but from the growers, because they're in it, they're trying it, they're working at it, they know the plants very well. And you just never know what some institutes are actually working on. So there is a little bit of behind closed doors work going on, and who knows what we'll see in the next 10 years.
It's quite exciting either way, I think.
Yeah, it's exciting. I mean, one of the caveats that I try to address with people that are interested in developing species is that this is a long-term approach, and if you're not factoring in the climate element, you could be wasting your time. So there's no point in producing coffee that grows in the same conditions as Arabica, because we need those climate tolerant coffees, or indeed producing a coffee that's 1 degree more tolerant of ambient temperatures if you're going to be facing 1.5, 2 or 3 degrees. So you have to have a vision, a projection of what's what the environment's going to be like. But, you know, it's saying that, you know, we are, of course, already under the influence of climate change. But one of the interesting things to come out of the media work is the hundreds, and I mean hundreds, several hundreds of emails and pieces of correspondence we've had wanting Stenophylla, wanting to try it, wanting to develop it. I mean, we don't have the material. It's not in our jurisdiction to provide that material. We don't have any rights over it, the ability to disseminate the material. But I think the key thing is that it's mainly coming from Arabica producers that are experiencing problems with Arabica. Don't particularly want to switch to Robusta, or can't switch to Robusta because it's too dry. We heard from Nishan's talk, I converted 80 inches, that's 2,000 millimeters. Well, that's quite a lot of rain. You know, a lot of growers can't grow Robusta. Arabica is actually a bit more drought tolerant than Robusta. So yeah, it's a question of thinking of what you need. But yeah, I'm sorry, I lost track there. So yeah, it's interesting getting that feedback, and that people already want something to replace Arabica, and they want that preferred sensory element that will give them the prices that they require to be in the profit zone.
And that actually brings us to a really good question from one of our quality manager, Thierry, because he's asking, is Stenophylla commercially viable, and is it compatible with the wild population's habitat itself? So I think it's kind of coming off what you're saying.
Yeah, you know, one of the interesting things about Stenophylla, and I've mentioned this, is when you look at the genetic data that's available, it's variable. It's more variable than you would expect. You know, given its distribution, it appears to have much more variability, in genetic variability and visible variability than Arabica. You know, fruit size, number of flowers, number of fruits, leaf dimensions are really variable. And Stenophylla comes from Greek Latin, and it means narrow leaf. And many of the plants have leaves that are, you know, really very narrow. But there's also plants that have leaves about the same size as Arabica. So really, really variable. I think that if we can, or, you know, the community or whoever can access and find that diversity and safeguard it, that will make a big influence, because you just don't go to one forest, pick a few plants, and there, you know, away you go. You've got to try lots of the variation to find something that is going to work and has the best qualities.
It's really interesting. I've got another question here from Josh Clark over at Clifton, and I thought I'd just
my daughter, yeah. I told her that I'm ringing the doorbell.
Of course, no worries. I'll do the plug while Aaron's not there. But yeah, Clifton and Aaron met in Full Circle Additional 1, and since they met, they've actually come up with a really interesting collab with an interesting project that Aaron's running. I'm just plugging your work with Clifton, Aaron. Obviously, Kew Gardens always looking for funding. So if anyone on the call wants to collaborate and has some capital to do that, research is not free, and obviously feel free to contact Aaron. But we'll go to Josh's question in this regard. So he says, in regards to cropping and harvest cycles, does Stenophylla seem to follow the same cycle? When are you next going to receive samples, and is the plan to cup again with a larger sample size? And how much attention we pay to processing? Because I think you mentioned that the processing was quite minimal on this one.
Yeah, the processing thing really surprised me, because when I said patio, I didn't mean a coffee drying patio. I meant somebody's front garden. And literally they were dried on a plastic chair, 3 days. Or actually it was 2 days, for some reason, dried for 2 days inside in the house, and then 3 days outside in the sun. So really minimal processing. And I think that would make Josh is right. I think there's huge potential there. You know, to get things, I mean, naturals are always far less complicated in terms of developing, you know, smallholder capacity. But yeah, what would happen if we wash them, dry them properly. Who knows? And the coffee that we cupped at Union wasn't super clean, but I was just amazed how good it was considering that processing. We are trying to get more cupping samples. The difficulty is the balance between if you have even 100 grams of green coffee, that's 100 grams of green coffee you're not propagating, and getting ready to go out to farms. And at the moment, the main thing is to get thousands, tens of thousands, hundreds of thousands, millions of plants, because that's what you need if you want to take this to scale. And every time you take a cupping sample out, you're reducing that. And there's a limit at the moment. There are very limited places where we can access material from the wild. We hope to be looking for more. But yeah, it's going to be, it's like all these things. You never know what's going to happen with this. And even since we published the paper, I think I've got the first 2 chapters of the book, because this is turning into the stuff that I can't tell you is happening. It's turning into one of those crazy stories, everything that's going on around this. But yeah, we just have to, try and do the best we can and see how this pans out. You mentioned our work in Uganda, so Stenophylla is one of the species we're interested in, but we're also really interested in liberica. It's great to hear the chance to talk this morning, and Eugenioides. Again, Eugenioides, of course, has been received great praise by many cuppers for being sort of so interesting and super sweet. And liberica, there's been some good reports from various cuppings across the world, particularly in Malaysia. But we've actually, I think we've got taste data, flavor data for about 20 different libericas now, and they're all so different. I think that's really super exciting to see where that can be taken. Yeah, so I think we've just got to keep our options open and keep exploring.
Brilliant. We've got a question from Azuz then. Says that Aaron has done a lot of work on forest coffee, particularly in Ethiopia. So what are your thoughts on forest and garden coffee's future? Will the production and quality increase to meet the demand?
Yeah, forest coffee is that's daughter's home is called. I think forest coffee's got a great future. It was really interesting to listen to Henry's talk about farm gate price. I think, given the biodiversity element and the carbon element, I think we can push forest coffee and shade-grown coffee into a higher category. And legislation is on its way to push that in terms of the value chain's impact on biodiversity loss. But it does cost the farmer, to plant shade and to grow coffee in that shade environment. We don't yet know whether Stenophylla requires shade, so it's maybe not a question of quality, but of whether you can grow it or not. So that's something that needs to be looked at. We do have some data that shows it can grow in under the sun system. But yes, as I say, a lot of work still to be done on the agronomy side of Stenophylla.
Yeah, I think going back to forest coffee as well, I think there's, in much the same way as when we talked about farm gate pricing, there's quite a few terms like forest coffee, garden coffee, shade grown coffee, which often tend to get used interchangeably when actually they're quite different. So we're actually going to be doing a talk this afternoon to kind of like try and define what those are and have a discussion about it with some people. Actually, I think you may have met them in Ethiopia, or the University of Huddersfield in Benchmaji.
Yes, yeah, yeah.
Yeah. So yeah, I think regarding the talks this afternoon, if anyone who is attending now wants to attend them, it is a separate link. So I just wanted to make that clear, because we've got 2 links for morning and afternoon. And I don't know if we've got any other further questions for Aaron at this stage, or if it's time for lunch.
Yeah, can I just make a quick point about forest coffee? I do think things are changing it'd be really interesting to hear the talk this afternoon. I think it's definitely worth tuning into. I think that the forest coffee and the forest association link is changing rapidly because of legislation. So the problem's always been is you have farms claiming that they're forest or agroforestry with, say, 10 trees per hectare. That doesn't compare to one with 100 trees and full canopy cover. So, but now we have the technology to actually review each farm in that respect and say what is the quality of the forest and what does the cover look like. So essentially, for in terms of certification, you can actually now put metrics on forest cover. So there's kind of nowhere to hide if you're cheating in terms of saying that your coffee is sustainable or encourages biodiversity, etc.
Yeah, absolutely. I think it's a very, certainly I know Rainforest has done a lot of work with looking at the history of a farm and how far can you go back to prove that you haven't just cut down the rainforest and set up a coffee farm. So I imagine, especially with more data and satellites, that will become easier to verify as well. Well, in that case, I think, thank you very much, Aaron.
No, thank you very much. It's been a very interesting morning. Thank you.
Yeah, we look forward to seeing how the research goes in the future.